Welcome to the lesson. I'm teacher Katimbo again. Today, we are going to look at fractions. Having seen fractions or looked at fractions in the lower classes, we are going to apply them today in P7. The teachers in lower primary told you or defined what a fraction is. We said a fraction is a part of a whole number, and they told you the types of fractions. The 4 types of fractions were given as proper fractions, improper fractions, decimal fractions, and I said proper fractions, improper fractions, decimal fractions, and mixed fractions. Now we are looking at application of the same fractions, and examples are here given. Example number 1 says, Tony spent a third of his salary on rent, 2/5 of the remainder on food, and saved 80,000 shillings. Find his salary. Now, you know when you have got a salary, it is a whole before being spent. And now when you start spending, you reduce from that whole number. That's why we start like, Tony spent a third of his salary on rent. You say rent equals a third. After spending on rent, you have automatically reduced from one whole number. So what remains is what is termed as the remainder. Like they say 2/5 of the remainder on food. You say remainder equals the other whole minus a third. Our whole number in terms of 3 is 3 out of 3. 3 out of 3 minus a third equals 2 out of 3. Now 2 out of 3 remains after spending on food. So after spending on rent. So somebody continuously spent on food. Meaning, if you have got 3 things, he is actually catering for, that is rent, food, those are expenses, then he saves the rest. Now these 2 remain for the other 2 because they are 3. 1 is rent, where a third has gone from one whole number, 2/3 remains. If 2/3 remains, is for both food and savings. So they say 2/5 of the remainder on food. So since the remainder is stated above as 2/3, you say food equals 2/5 of 2/3. This of means times, or means multiplication operation. So you multiply to replace that word of. That's 2/5 times 2/3. 2 times 2 is 4. 5 times 3 is 15. Now, remember 2/3 were for both food and savings. And now food is 4/15. So meaning the other remaining one is actually for savings. That's why you say fraction saved. These 2/3 that remained after spending on rent minus the food now. So 2/3 minus 4/15, whereby the LCM of the denominators, that is 3 and 15, is 15. We are going to multiply each of these 2 by 15. 2/3 times 15 minus 4/15 times 15. By 3 once, by 3 get 5. 15 divided by 15 once, and so does it go once. You remain with 2 times 5 minus 4 times 1 as seen here, out of the LCM, which is 15. 2 times 5 is a 10, minus 4 times 1, which is a 4, out of 15. So that is 6 out of 15. In your multiples, you'll find that 6 and 15 are both multiples of 3. So they are reducible. So we divide either party by 3. So 6 divided by 3 as well as 15 by 3, you get 2 out of 5. So 2/5 is actually saved. These are the savings in terms of fraction. But they are saying, and saved 80,000 shillings. We have found out, fraction-wise, he has saved 2/5. And the actual amount was actually predetermined as 80,000 shillings. So that's why we say 2/5 is saved, represents the 80,000 shillings saved that day. So we say 2/5 represent that 80,000 shillings, or 2 out of 5, or 2 of the 5 parts represent 80,000 shillings. So therefore 2 parts represent 80,000 shillings. What about a single part? 1 part represents 80,000 shillings divided by 2, such that 1 part represents 80,000 shillings. What about the total of 5 parts? So 5 parts represent 40,000 shillings times 5, whereby 4 times 5, you get 20, and then you add on 1, 2, 3, 4 other zeros. So 5 parts represent 200,000 shillings. Therefore, 200,000 shillings was this man's salary. So that's how we apply that number. Then example number 2. Example number 2 reads, after covering 3/4 of the journey, Ben had 60 kilometers to cover. I repeat, after covering 3/4 of the journey, Ben had 60 kilometers to cover. Here, you must be careful about the service 60 kilometers render here. What about 60 kilometers? 60 kilometers is the journey yet to be covered, because they are saying Ben had 60 kilometers to cover, so they are yet to be done. What about 3/4? 3/4 was covered. So, meaning 60 or 60 service is actually opposite to the 3/4 service. Why? 3/4 of the journey was covered, whereas 60 kilometers were uncovered. So this 60 helps us know what we must ascertain before anything is done. What must we then ascertain? The fraction yet to be covered, which is dubbed uncovered here. So fraction uncovered. Remember, before covering a particular journey, you have the whole of it to cover. Now, you get a whole minus 3/4 to know the uncovered, because the 3/4 is already covered. So you say a whole journey minus 3/4. So in terms of 4, a whole is 4 out of 4. 4 out of 4 is the same as 4 divided by 4, which is a replacement of 1. You say 4 out of 4 minus 3 out of 4. Or 4/4 minus 3/4, which is equal to a single quarter, 1 out of 4. So 1 out of 4 is uncovered, so the 60 kilometers. Therefore, a quarter of the journey represents 60 kilometers. Why does it represent so? Because both are uncovered. You say a quarter represents a 60 kilometer journey. A quarter, one of the 4 parts. So therefore, 1 part represents 60 kilometers. What about 4 parts? 4 parts represent 4 times 60 kilometers. Then the 4 parts represent 240 kilometers. That's the length of the whole journey. Whenever they ask you how long, that adjective long has got an abstract noun, length. You say therefore 240 kilometers was the length of the journey. That's what you conclude. But you must know the service a figure given renders. Then you go in that line. Since 60 kilometers were yet to be covered, that's why you start by saying fraction uncovered. After getting it, it represents the 60 kilometers because both are in the same umbrella. Now, we shall go to example number 3. We shall look at example number 3. Example number 3 reads, a tank was 2/3 full of water. A tank was 2/3 full of water. Was it full? No, it was just 2/3 full of water. When a quarter of the water in the tank was drawn, it was drawn. Good. 2,500 liters remained. Here, somebody must know what 2,500 liters stand for. They stand for the remaining number of liters of water. So meaning you have to look for the fraction that remained. But unlike the first 2 examples, here we shall not use a whole number. Why? The tank was not full. It was 2/3 full of water. Then somebody must take note of the word of. They say a quarter of the water in the tank. A quarter of the water in the tank. What was in the tank? It was 2/3. Somebody drew. To draw is to like take away or fetch out, and then somebody uses it. So he drew some water. He took away. Which operation respects the word taking away or drawing? That is the subtraction operation. So you must use a minus sign of subtraction operation in order to work out this number. Remember, 2/3 of the tank was filled with water. Then somebody came and drew a quarter of that water. So to get the fraction that remained, you get what was contained in the tank, which was 2/3 minus a quarter of the 2/3. 2/3 minus a quarter of it. So you will get what remained. So that's why we are saying fraction that remained. It is 2/3 minus a quarter of the 2/3. Because they are saying a quarter of the water in the tank was drawn. The water was 2/3, or a tank was 2/3 full of water. And somebody drew a quarter of it. That's why you say 2/3 minus a quarter of the 2/3. Then you go down. Remember I said of is represented by a multiplication operation. You say 2/3 minus a quarter times 2/3. Now, if it's reducible, please, you reduce. You say by 2 once, by 2, 2. So you say 2/3 minus a sixth. Where does a sixth come from? From 1 times 1 as numerators and 2 times 3 as denominators. So get 2/3 minus a sixth. You apply LCM of the denominators 3 and 6 as 6, and say now 2/3 times the LCM 6 minus a sixth times 6 out of the LCM 6. So we divide by 3 once, by 3 2, by 6 once, and by 6 as well once. 2 times 2 minus 1 times 1 out of the LCM 6. You get 4 minus 1 out of 6, which is 3/6. 3/6 are both divisible. 3 and 6 are both divisible by the 3. By 3 once, divide by 3, you get 2. So a half is the fraction that remained. But remember, 2,500 liters remained. And a half has been ascertained as the fraction that remained. That's why we say a half represents 2,500 liters, meaning a half of the tank holds 2,500 liters. Now the question reads, find the capacity of the tank when full. We have already seen that a half of the tank represents 2,500 liters. What about a whole tank? So look at the numerator, which is a 1. You say one part represents 2,500 liters. Then the two parts will represent twice 2,500 liters to get 5,000 liters. Therefore, you say 500 liters, the capacity of the tank when completely full. Here, you must note of the word of, as well as drawing, and the service rendered by 2,500 liters to answer that question. That is how that number is supposed to be looked at. Any question? Your silence shows that you have actually understood. Having looked at the 3 examples, we shall go to example number 4, which reads, 3 taps A, B, and C are connected to a tank. 3 taps A, B, and C are connected to a tank. Tap A, turned on alone, takes 3 minutes to fill the tank. Tap B takes 6 minutes, while tap C takes 4 minutes to fill the same tank. How long will the 3 taps take to fill the tank if turned on at the same time? Now, when you look at this question, you will find out that looks like it's not connected to the fractions. It is fractional. Ask the teacher in which way. As we say, the fraction is a part of the whole number. When you open a tap, connect to a tank, it releases water little by little. Hence, it is pouring out or releasing out a fraction of water in the tank. That's why you apply fractions here. So, how then do we apply or work out this number? You look at the duration taken by a particular tap connected to the tank. Look at tap A, for example. Tap A turned on alone takes 3 minutes. To turn on is the same as to open. The fact being that it takes 3 minutes, it means every minute it will have to pour in the same fraction of water, which is a third. Hence, being that tap A takes 3 minutes to fill the tank, you apply it fractional in this style. You say tap A fills a third of the tank in 1 minute. Then read the next tap. You say tap B takes 6 minutes to fill the same tank. In application of fractions, you say tap B fills a sixth of the tank in 1 minute. Then you go and read tap C. While tap C takes 4 minutes to fill the same tank. In the application of fractions, you say tap C fills a quarter of the tank in 1 minute. Now, what are they all doing? The main verb here is filling. If they're actually filling, filling is like adding more water onto the already that is in existence. Therefore, you apply addition. You say in 1 minute, all the 3 taps fill a third plus a sixth plus a quarter. Why are we adding? All are filling. They're actually adding on to the original water in the tank. Look at the denominators you have. We have 3, 6, and 4. What's the LCM of 3, 6, and 4? The LCM is 12. So you multiply each of the fractions here by the LCM predetermined. You say a 6 times 12, rather a third times 12 plus a 6 times 12 plus a quarter times 12 out of the LCM, which is 12. Then divide by 3 once, 12 by 3, you get 4. 6 by 3, you get 1. 12 by 3, you get 2. 4 by 4 once, and 12 by 4, you get 3. I repeat, 3 divided by 3 once, 12 divided by 3 is a 4. Here the divisor is 6. 6 divided by 6 once, 12 divided by 6, you get 2. 4 divided by 4 once, and 12 divided by 4 is a 3. Write the outcome out of 12. That is 1 times 4 plus 1 times 2 plus 1 times 3 out of 12. Get the products. 1 times 4 is a 4. 1 times 2, you get a 2. 1 times 3, you get a 3. Hence, we have got 4 plus 2 plus 3 out of 12. So 4 plus 2 plus 3 is a 9. 9 is out of 12. As you will find out, or you are seeing, 9 and 12 are both multiples of 3. Reduce 9 and 12 by 3. 9 divided by 3, get 3. 12 divided by 3, you get 4. Thereby getting 3/4 as being filled in a single minute by all the 3 taps. But the main question reads, how long will the 3 taps take to fill the tank if turned on at the same time? Remember, I've got 1 tank to which all the 3 taps are connected. You will realize that when 2 or more people are working on a particular thing or particular job, or they are having a particular duty to fulfill, and it's only one, there will be what is called division of labor. For example, you are asked to sweep a particular room and you are 3, you will have to divide that room in 3 or into 3 equal parts, thereby working or having a particular kind of portion to work on, but when it is evenly divided. So since we have got 1 tank to which the 3 taps are connected, and we have found out that they fill 3/4 in 1 minute, so we shall have that 1 tank divided by 3/4. Then you go 1 times 4 out of 3, the reciprocal of 3/4. Then 1 times 4 is 4 out of 3. 4 out of 3 is the same as 4 divided by 3. 3 divided by 3 is 1. 4 divided by 3 is 1, remainder 1, which is 1 1/3 minutes taken to fill the tank when all the 3 taps are turned on at the same time. Remember, you will have to involve this wording. Don't just say tap A equals 1/3. Somebody will wonder, or one will wonder where I've got 1/3 from. Write the whole statement very well. The fact being that tap A takes 3 minutes. Apply fractions in the statement like this. You say tap A fills 1/3 of the tank in 1 minute. So do you do to all other taps. You want to introduce fractions in the whole story and then get your 5 marks. Example number 5 reads, tap Q takes 4 minutes to fill the tank, while tap R takes 8 minutes to draw water out of the tank. How long will it take to fill the tank if both taps are left open at the same time? The difference between example 5 and example number 4 is, in example number 4, all the taps are filling, whereas in example number 5, tap Q is filling, whereas tap R is drawing out. To draw out water is to empty. So one is emptying, another one is filling. Now somebody or a child will have a question. How comes that the tank will later be filled when one is emptying? The answer to that question is, the bigger the tap, the less time taken to fill a tank. Whereas the smaller the tap, the smaller the tap, the more time taken to fill the tank. So the fact being that tap Q takes less time compared to tap R, then tap Q, we have to fill in or to put in more water compared to what is actually drawn out per minute. That's why you say tap Q fills a quarter of the tank in 1 minute, because it takes 4 minutes to fill the tank. Whereas tap R draws an eighth of the tank or an eighth out of the tank in 1 minute. One is drawing, another one is filling. Now, you say fraction filled in 1 minute. You get a quarter minus an eighth. Why do you subtract? Because one is emptying. One is drawing out. To draw out is take out. So is to deduct, is to like use. So you subtract or take away an eighth that's drawn per minute. So you say a quarter minus an eighth. Remember the heading is fraction filled in 1 minute. That is a quarter minus an eighth, whereby the LCM is 8. So LCM of 4 and 8 is 8. Multiply a quarter and an eighth in the next step by the LCM. You say a quarter times 8 minus an eighth times 8. Divide by 4 once, divide by 4, that's 8 divided by 4, you get 2. 8 divided by 8 once, so it's the other 8. So write the outcomes, 1 times 2 minus 1 times 1 out of 8. 2 minus 1 out of 8, which is an eighth, that is filled per minute. Now the question, or the main question reads, how long will it take to fill the tank if both taps are left open at the same time? Remember, it's about filling one tank. So get 1 divided by an eighth, then 1 times the reciprocal, which is 8 out of 1, which is equal to 8 divided by 1, 8 means. So much as one is emptying, the other one is filling, is actually filling in more water per minute. That's why at the end of the day, the tank will get filled. But it will take more time to get filled for one is emptying, it's taking or disturbing the other one that's filling. So we have come to the end of this lesson. Teacher Katimbo, if you actually need to get more explanation, the contact is 0776 251655. So that's the end of the lesson. Goodbye.